Okay, welcome back. So we're going to look through some examples here. Something to keep in mind, notice it says f of x. Remember that y is equal to f of x. That saying f of x is the same as saying y. And that our general form of the vertex equation is y is equal to a times x minus h squared plus k. And so we've got f of x. A, notice here, is the number before the parentheses. And just like a variable, if it doesn't have a number in front of it, we can always assume that number to be 1, because 1 times x minus 1 squared would be x minus 1 squared. And so we have a is equal to 1. And h is this value right here, x minus h, x minus 1. And so it's 1. And k is this number right here, and so that's negative 4. Direction of opening, it opens up because a is equal to 1 and 1 is greater than 0. It's positive, so this thing opens up. And our vertex, we can read it right off of the vertex form, which is why the vertex form is nice, because we can just read it. It's 1 comma negative 4. All right, word to the wise here. Notice it's positive 1, negative 4. Even though it says x minus 1, because the general form is x minus h. And so x minus 1, the value is 1 that you read off of there. It's a little bit counterintuitive. You would expect it to be a negative 1 because this is x minus 1. So it's sort of the opposite of what you'd expect. Is it a maximum or minimum point? Because it opens up, there is a lowest point, but there's no highest point. Notice the arrows that point up. It continues to go up forever till positive infinity. And so it is a lowest point, so there is a minimum. And the axis of symmetry is the same as the x-coordinate of the vertex, so we just say x equals 1. It is important that you write that x equals 1 and not just 1, because x equals 1 is an equation for a line. Speaking of which, let's go ahead and graph that. X equals 1 is this vertical line here. Now, it's not technically part of the graph, but it does help us to graph. We also need to graph our vertex, 1, negative 4, is right here. And since it opens up, I'm going to label it down here. This is 1, comma, negative 4. All right, my y-intercept. Now, the y-intercept, as we talked about in the notes, is when you set x equal to 0. And so we're going to go over here to the side and just say y equals, go to our equation, parentheses, instead of x, I'm going to say 0 minus 1 squared minus 4. And then I'm going to evaluate this to find the value of y. So I'm going to say 0 minus 1 is negative 1 squared minus 4. Negative 1 squared, a negative 1 times a negative 1 is positive. So that's 1 minus 4. And that's equal to negative 3. So our y-intercept is at the point 0, comma, negative 3. And let's graph it. So we put this on the graph. 0, negative 3 is this point right here. And this is where the axis of symmetry is really nice. Because it is 1 unit from the axis of symmetry, I move on the other side 1 unit, and there I can graph another point. You can verify that that's correct by putting 2 into the equation to show that the corresponding y value would be negative 3 also. The domain is all real numbers, and we want to write that in both like this, all real numbers, but also in interval notation, which just means it goes from negative infinity to positive infinity. So both of those answers are important. We want you to know how to work through both of those different notations. The range, because it opens up, the lowest value, we talked about, it has a minimum. The lowest value would be negative y. So we would say y is greater than or equal to negative 4. And then in interval notation, that would be the lowest value. You always start the lowest value, and the lowest value would be negative 4. And then the highest value doesn't have one, so it goes up to positive infinity. All right. As we go to graph this, we'll probably want at least 1 or 2 more points. So let's look at what happens at 3. X equals 3. So we put y equals 3 minus 1 squared minus 4. 3 minus 1 is 2 squared minus 4. And 2 squared is 4. And 4 minus 4 then is 0. So at 3, we're at 0. We found one of the x-intercepts. And notice that it's 1, 2 units away from the axis of symmetry. So then we can go 1, 2 units on the other side, and then we have another point. Let's also see what happens at 4. So instead of x, I put in 4. 4 minus 1 is 3. 3 squared minus 4. 3 squared is 9. 9 minus 4 would be 5. So at 4, we're up to 5. And it's 3 spaces away from the axis of symmetry. So I go 1, 2, 3 on that same line, and then we are at another point on the parabola. So now we can graph this parabola. Remember to use curves, not straight lines. The graph of a parabola is U-shaped, not V-shaped. And to put your arrows at the top of this, all right, and that's our first example, complete with graph. Well, let's look at the next example. We've got negative 2 times the parentheses x plus 2 squared minus 1. So the a value, we can just read it right off of there. It's really nice. Negative 2 h. Now here, I'm going to rewrite x plus 2 inside the parentheses. I'm going to rewrite that as x minus negative 2 squared. And I do that so that you realize plus 2 is the same as minus a negative 2. And that's because the general form of the vertex form of the equation is x minus h. And so here we can see h is negative 2. And k is minus 1. Direction of opening goes down because a is equal to negative 2. And negative 2 is less than 0. It's negative. So it opens down. The vertex is at the point hk, negative 2, comma, negative 1. Is it a maximum or minimum point? Because it opens down this time, that vertex is a maximum. And I'm trying to model here what I'd like you to do. Let's put boxes around our answers because it makes it easier. You might have done some calculations, but to put a box around your answer makes it easier to pick out what your answer is. Axis of symmetry. We've got x equals, and it's just the x coordinate of the vertex. So x equals negative 2. While we're at that, let's go ahead and graph that. Let's graph our vertex is at negative 2, negative 1. So that's that point over 2 in x, and over to the left 2 in x because it's negative, and down 1 because it's also negative. And then we want to graph our axis of symmetry. Remember, the axis of symmetry is a vertical line, goes through the vertex. If you graph the vertex, then you just graph a vertical line. And remember that when you're labeling that vertical line, it's x equals, and then the number. In this case, x equals -2. Okay, and our y-intercept. For our y-intercept, we want to set x equal to 0 and find the y value. So y equals -2. Instead of x, I'm going to write 0 plus 2 squared minus 1. That's -2. 0 plus 2 is 2 squared minus 1. 2 squared is 4 times -1, or with the -1 on the end. -2 times 4 would be -8, and I've got -8 minus 1, which is -9. So our y-intercept is at 0, comma, -9. Let's just sort of show where that would be. We're at -6, so down here, -7, -8, -9. It'd be down here, about right here, where the graph would cross the y-axis. The domain. Let's make that point a little bigger. Domain for all parabolas, all quadratic functions would be all real numbers. And then again, we can write this as it goes from -infinity to +infinity. Our range, because it opens down, we would say y is less than or equal to the y value of the vertex, which is -1. Or, in interval notation, the lowest value, because it's pointing down, it has no lowest value, so we'd say it goes from -infinity on the downside to the upside, which is it goes up to -1. And it can be equal at -1, so we use a bracket instead of a parenthesis. And that's the same thing as what we put here. So now we want to graph this thing, and I want to see what happens at -1 when x is equal to -1. So I'm going to put y equals -2 parentheses -1 plus 2 squared minus 1. And then -1 plus 2 is 1 squared minus 1. 1 squared is just 1, and 1 times -2 would be -2, so I have -2 minus 1, which would be -3. So at 1, I'm down here to -3. And again, we use the axis of symmetry. On the other side of that axis of symmetry, just 1 unit away, would be another point. And so here we can graph our parabola. Go up. Again, it's really tempting to make it just pointy. Don't make it pointy. Make it a curve, even if it's just a little curve up there at the top. That's a curve. And then it goes down. Sure you draw your arrows on the end. And that's what this looks like. We're learning to graph our quadratics. Hopefully at this point you're becoming somewhat proficient at graphing quadratics. Come in on Fridays if you need help with factoring or graphing or any of this stuff. Please come in. I'm happy to help.